Okay, guys. Hey, Michael, are you back? Can you hear me? Okay, I guess Michael is still away from the keyboard. In the meanwhile, guys, let me do a quick recap from the previous sessions. So we talked about IPv4 addresses in the first class. We've talked about the range of IPv4, what the properties of IPv4 addresses are, and how do you convert a binary address to a human readable decimal address. Okay, and then we understood what's the first IP, what's the last IP, what's the sequence of IPs in between. Okay, and after that, in the last class, we talked about the classes, class A, B, C, D, and E. We understood the range for each class. We tried to understand the categories of public and private IPs and their ranges as well. We did a small exercise on, again, dividing public and private IPs from the range. Kiran, did you get a chance to memorize these numbers? Do you, I mean, can you categorize them without looking at this table?
Sir.
Sorry, Kiran, I couldn't get your voice. I couldn't hear you properly. Okay, no problem. No problem. So again, please try to memorize this at the earliest so that as soon as you look at an IP, you have to figure out which one is a public one and which one is a private. Because in the upcoming classes, we're going to be working on that a lot. Be working on a lot of public and private IPs. Okay, so we understood the relevance of each class. We understood how many devices could be hosted in class C, how many can be hosted in each class B network, and how many can be hosted in class A as well. Okay, today we're going to talk about some other concepts such as subnet mask, okay, and DHCP and DNS protocol. Okay, so Michael, are you back? Can you hear me?
Yes, sir.
Perfect. Cool. So when you go to your command prompt, let me record this session just a sec.
Recording in progress.
Right. So when you go to your command prompt and when you run the command ipconfig, this shows you your IP address, exactly the private IP. And if you notice, it shows the first line IPv4 address 192.168.0.4. And under that, there are two other pieces of information. There's something called as subnet mask and there's something called as default gateway. Let's talk about that. What is subnet mask? So for us, when we try to look at an IP, we know each class belongs to, what IP belongs to what class from the network and host portions. Class A has one network portion and three host portions. Class B has two network portions and two host portions. And class A has three network portions and one host portion. But how does a computer understand that? How does a computer know which IP belongs to what class? So for that, it uses something called a subnet mask, where it substitutes the network portion with the value of 1 and the host portion with the value of 0. So wherever I have a network portion, I've assigned all ones in that octet. And wherever there's a host portion, I've assigned all zeros in the octet. And when you convert that from binary to decimal, you get the subnet mask value for that IP. So for class A, the subnet mask for any IP is 255.0.0.0. For class B, where you have two network portions and two host portions, the subnet mask is 255.255.0.0. How are we getting this 255? Just by converting all ones from binary to decimal. How are we getting the 0? Just by converting all zeros from binary to decimal. And finally, when you talk about class C, where it has three network portions and one host portion, you have 255.255.255.0. And if you notice over here, the address that my system is getting is 192.168.0.4. You know that this is a class C address. And since it's class C, the subnet mask is 255.255.255.0, what we see on the screen. Okay, so again, you might have a question, where do we use this? This is used in the procedure of assigning your own IP address. So your system has two methods of getting an IP, the private IP. Either you can manually assign it, or it can get it automatically from a DHCP server. So if you had to manually assign, yeah, Michael.
So why is your why are you using the class C? Do you have multiple companies? Because if you're using you're supposed to use a class A. Because
why? I'm connected from my home network. So in my home, I don't have a necessity to connect more than 4 or 5 devices. So that's why I'm using a class C address. So in my private network, I just have 5 devices or 6 devices, not more than that. And hence I'm sticking to class C. If I were in an organization, a much larger organization, such as a multinational company or again an ISP network or whatever organization it be, if it uses more than 255 devices in each network, then I would have to go with class B or class A. Since I don't have the
Oh,
necessity.
I was thinking the reverse. I was thinking that when you have less than 255 in organization, that's when you use class A.
No, if you remember in the last class, Michael, do not forget these concepts. Class C can only connect maximum of 255 devices in each network.
Okay.
So if you notice,
Okay. I got it now. I was thinking of the reverse. Okay, I put it upside down. Okay.
okay. So class B 255, class C 255, class B 255 into 255, and class A 255 into 255 into 255.
Okay, I got it now. Okay, yeah.
Okay. Now proceeding further. So if you remember, I've just told you that there are two methods of assigning an IP to your system. Either you can assign it manually yourself, or you can get it automatically from a DHCP server. So let me show you both the methods now. If you want to assign a manual private IP to your system, you have to go to your control panel. And in the control panel, you go to network and internet settings. In this, you go to network and sharing center. And in network and sharing center, you click on change adapter settings here. And in that, you select the adapter for which you want to change the IP address. So right now I'm connected on my Wi-Fi adapter. So I have to right click on that, click on properties. And in properties, I have to select IPv4, Internet Protocol version 4 properties. And you can see there are two methods. Now, right now, at the moment, I'm getting an IP address from a DHCP server. What's a DHCP server? We're going to talk about that in a minute. Don't worry. Okay. But if you wanted to assign a manual IP to your system, you would have to select the second option and assign the IP address here. So whatever IP you wanted to assign, you have to manually enter the IP here, 0.100, let's say. Okay. Now, when I click on subnet mask, I have to specify 255.255.255.0. This is for class C. Default gateway. Now, this is the address for the router. So default gateway is the other fancy name given to a router. It acts as a gateway for your network. Whenever you want to send a packet to the internet, it needs to reach the router first, and from the router, it goes to the internet. So it acts as a gateway for all your devices to connect to the internet. And your default, your router always gets the first IP in the network. So if you notice, default gateway is 192.168.0.1. So I have to mention the same IP address over here, 192.168.0.1. Okay, and it's asking for something called a DNS server address. If you don't know what to enter here, always just type 8.8.4.4. This is the default DNS address for a Google DNS server. Now, we have not talked about DNS servers. I'm going to explain that in a minute, guys. Okay, so if you don't know what to enter here, just go to your browser, search for Google DNS server address, and it provides you two addresses, 8.8.8.8 and 8.8.4.4. You can use any one of them. Okay, and now when you click on OK, this IP gets assigned to your system. Okay, that's how you manually assign an IP. So this was the procedure that you followed in the olden times. So if you were the network administrator for an organization or even for your home network, you would have to manually go and assign an IP to each and every system. Okay. So if it's a small network, it's not that big of a problem. It gets done in 5-10 minutes. But if you're working for a multinational company and if it has like thousands of devices, you going to each system and manually assigning an IP to each of these devices would be a very hectic task. So that's why they invented something called a DHCP protocol, which stands for Dynamic Host Configuration Protocol. Okay. The name itself tells you what it does. It is used to dynamically or automatically configure an IP address to every host in the network. So it is used to automatically assign an IP to each and every system that is connected in the network. So rather than you manually going to each system and assigning an IP, if you have a DHCP server in your network, that server takes the responsibility of assigning an IP to each and every device. And that happens with something called the DURGA process. So let's talk about this. So any questions up to this point, guys? Kiran, Michael,
No, sir.
Madhu, Saklin. Hi, Madhu, and hi, Mohammed, Saklin. Can you hear me, guys? I guess
Yes.
you're joining for the first time today. Madhu and Mohammed. Okay.
Yeah, right. Your first day. I can hear you.
Okay, hey Mohammed. Again, you might have missed out a couple of sessions. This might seem a bit confusing to you if you're not familiar with the networking concepts. So again, this is not the actual demo circuit. Mohammed. So we have
No,
taken
it's
demo.
okay. Yeah, it's
Right.
okay.
Sure. Cool. Right. So let's talk about the DHCP server now, guys, and what this DORA process is. Okay. So now, whenever you talk about a DHCP server always has a pool of free IP addresses. So in our home networks, our Wi-Fi router itself acts as a DHCP server. So this is my Wi-Fi router, which also acts as my DHCP server. It always has a pool of free IPs. Okay, so the pool starts again. Your router also needs an IP. It takes the first IP in the network, 0.1, and the pool starts from the next IP, 192.168.0.2, and goes up to the last IP, let's say 192.168.0.254. Okay, 255 is never used for any device, guys. It's called a broadcast address. It's always omitted. Even the first 0.0 is removed. It's the network ID, network IP or network ID. That's also excluded. So the only usable IPs you would have is from 1 to 254. Okay, 0 and 255 are always excluded. Okay, so now this is the pool of IPs that a DHCP server has. Now, whenever there's a device in the network which is connected to this DHCP server, this DHCP server automatically assigns IPs to them. Okay, with the help of something called DORA process. So this gets the IP 0.2 and this gets the IP 0.3 accordingly. And whenever an IP is assigned to a system, those IPs are removed from the pool so that they don't get assigned to the same IP to other systems again. Now the pool starts at 0.4. Okay, so what is this DORA process? How are these IPs getting assigned? Let's talk about that. So let's say I bring a new device in the network. So let's have connected my mobile phone or my new laptop to the network. Okay, so whenever you select that option, obtain an IP address automatically in the control panel. So just a second, let me show you that. So whenever I go to my route adapter IPv4 properties, you can see there's this option, obtain an IP address automatically. So whenever this option is selected for the system, what your device starts doing is it starts searching for the DHCP server. How does it do that? It sends a broadcast packet. So it sends a packet to each and every other system in the network. And this packet is called the discover packet. It's trying to discover where the DHCP server is. So it's asking each and every device, are you the DHCP server? Are you the DHCP server? Are you the DHCP server? So when they reach the wrong systems, the packet is just dropped. It is not responded to. But when it reaches the correct DHCP server, that server responds back. Hey, you were looking for me. I am the DHCP server. And since you are new to this network, I can offer you an IP address, the available IP, which is 0.4. So when that IP is offered to the system, your system says, hey, thanks for offering that IP. I request you to allocate that IP to my system and remove it from your pool. So a request is sent to get that IP assigned. And for that, your DHCP server sends a confirmation, which is also called as an acknowledgement. So with this acknowledgement, it acknowledges the request and confirms that IP to the target system. And once
so it's like a four-way handshake.
Kind of, yeah. It's a four-way handshake between the client and the DHCP server, exactly. And with that final acknowledgement, when the IP is assigned to the client, that IP gets removed from the DHCP server. And now the pool starts at the next IP, 0.5. And this procedure of discover, offer, request, and acknowledgement is called the DORA process. Okay, is that clear, guys? Again, all of this happens in a very short duration, like around 1 or 2 seconds, not more than that. If you own an Android phone, I'm pretty sure you have observed this process. So whenever you connect to a new Wi-Fi router, after entering the password, for a very short duration, you see a message saying obtaining IP address. Not sure if this is available on Apple phones or iPhones, but this is very visible or predominant in Android phones. Whenever you connect to a new Wi-Fi router, after entering the password, it says obtaining IP address. So that procedure, the procedure that runs in the background during that process is the DORA process. Okay, so this is the procedure that is used by every DHCP server to assign an IP automatically to each and every system in the network. Okay, is that clear, Michael? Kiran?
Yes, it's clear. But I have a question.
Sure.
So so the router and the DHCP server, they work together in the network layer. to provide authentication?
To provide an IP address, not after the authentication. So when we connect to the router, we need to enter the WPA password, the WPA or
Okay,
WPA
to provide
password.
the IP address. Okay.
Provide an IP
Okay.
address. So once the password is
So,
authenticated to your system,
so
the router, yeah.
right. So every router has to
Mhm.
have a DHCP server on the side that provides the IP address.
Not necessarily, but most of your home Wi-Fi routers, the Wi-Fi routers usually come with a DHCP server or DHCP
Okay.
protocol. Okay.
Okay.
If you take your normal networking routers in organizations, you have routers which only serve the purpose of routing packets. They might not contain the DHCP service.
Yeah,
Okay.
that's what I was thinking about. Okay.
So, but your home Wi-Fi routers, which are also commonly called as access points, they do come with a DHCP protocol pre-installed.
Okay.
Right. Now let me show you this a bit practically as well. So at in my home network, the router that I use, the access point which I use also works as a DHCP server. Let me show you that. Kiran, any questions up to this part?
No, sir.
Any doubt? Okay,
No, sir.
right. Oh, just a second. Yeah. So if I go back to my browser now, and if I access my router's IP in the browser 192.168.0.1, this gives me my access points login page. I'm using a TP-Link router. So if I log into my router here, I can go to my network settings for my router. And in that, if I go to my LAN settings, you can see it acts as a DHCP server as well, where it is getting the first IP. And there's a pool here from 0.2 to 199. So I'm not using all the 254 IPs. I'm only using the first 199 IPs. That's also too many because I don't have more than 5 or 6. Okay. So again, the only client or the only system that I have running in my network is this one system, is nothing else. So whenever I connect a new system in the network, that gets added as a client here. Okay. So this is the default gateway address. This is the pool of the DHCP server, out of which each IP is assigned to a system. Okay. And then there's something called as a lease time. Lease time is the duration for which an IP gets assigned to a system. After that lease time, that device needs to perform the DORA again. Reason being, if the device is not available, if the device is not working, that IP should be wasted. So after the lease time, the IP goes back to the router, to the DHCP server. And if that device is still up, it performs the DORA again and gets a new IP after the lease time. Okay. So that's what a DHCP server is used for, to automatically assign an IP from the pool to each and every system in the network. Okay. Mohammed, is this clear for you as well? Any questions? Okay, assuming it's clear for everyone, let's go to the next topic, which is DNS server. Now, what is a DNS protocol? So when you were entering a manual IP, it was asking you to enter something called as a DNS server IP. What is that? Why do we need it is the main question. So now when you talk about DNS servers, which stands for domain name service, it is a protocol to translate IPs to host names. What I mean by that is, again, to explain this with a very simple example, a DNS server is like a contact book application for websites. Okay, what I mean by that is, if you have a mobile phone with you, specifically, no matter what operating system, whether it be Android or Apple, you have a contacts application. And that contacts application's job is to link a contact name with a 10-digit contact number. Okay, so we humans are terrible at remembering numbers, or a huge list of numbers. So when we want to dial up a number, we search for it by the contact name assigned to it. Okay, and when we search for that number and hit the dial button, your phone, the 10-digit SIM card on your phone, dials the 10-digit SIM card. It is not relevant to the SIM card what you save the name as. It is only concerned with the 10-digit number that it owns and it needs to call. Okay, so the connection happens between your 10-digit SIM card number and the target 10-digit SIM card number. Similarly, when you go to your browser, and in the browser, when you enter www.google.com, your browser actually doesn't understand this language. It doesn't know what www.google.com means. Okay. But when you're hitting enter, the page loads up over here. Okay. So the browser is actually concerned with the internal public IP for google.com. So this Google website must have been uploaded or must have been served or you could say hosted from a physical server. Okay, and that physical server might be having a public IP. So your browser is only concerned with that public IP address that it needs to connect to, and that address is received from a DNS server. So your ISPs, internet service providers, or other organizations in between have a DNS server, and that DNS server contains records telling you where is the website hosted. So google.com is hosted on so-and-so public IP, bing.com on so-and-so public IP, youtube.com on so-and-so public IP, yahoo.com on so-and-so public IP. So whenever you request for a certain website in your browser, that request first goes to a DNS server. In the DNS server, it resolves or it tries to translate what that domain's public IP is. And once it fetches that public IP, it redirects to that certain server. If I have to show you this as an example, you can open up your command prompt, and in the command prompt, you can run a command called ping, P-I-N-G, and you can enter a domain name, let's say www.google.com itself. Now when I hit enter, you can notice my system now tries to connect with Google. Ping is a command to send a couple packets to the target server and wait for a response. So it sent 4 packets, it received 4 packets, and there was 0 data loss, which means the connection is perfectly all right. There's nothing wrong. But if you notice, when I'm connecting to google.com, it is getting a reply back from a number here, an IP address. And if I copy this number, this IP address number, Control C, and if I paste it back in my browser, over here, same IP address, 142.250.193.100. And if I hit enter now, carefully observe what happens. It loads google.com. So this was the actual address for google.com. But we humans don't need to remember this. The reason being, there's a DNS server in between, which is linking this IP address with this domain name. So it is linking or translating a domain name to an IP, and vice versa. So we humans don't have to remember the address for each, the numerical address for each website. We can just connect to it with the domain name of this name, or the host name, or the domain name for the website. Okay, so the DNS server does the job of resolving the IP to the domain and vice versa. Okay, again, these IPs could keep changing as well. They could be dynamic. Every single day they could change. So rather than you remembering or trying to know what the new IP is, you have a domain name fixed. Okay, and that DNS server makes it easier for you to link that domain name to the IP. Okay, so is that clear, guys? So basically, your DNS server is a contacts book application for websites. It links each domain name with its exact public IP. And with that, it knows what server to reach and what web page to load up on your browser when you request for it. Is that clear, guys? Michael, Kiran, Mohammed?
Very, very clear.
Perfect. Kiran? Madhu?
Okay, I'm clear.
Perfect. So yeah. Now, along with this, there's one more concept that I have to talk about, which is called CIDR for today. And yeah, that would be the last demo, guys. So again, tomorrow we're going to go into another topic, a practical topic called lab setup installation. Okay, so let me talk about this CIDR value. We'll also, again, tomorrow it's going to be about lab setup installation, how we install the practical lab, the Kali Linux lab, okay, the VMware virtual machine labs. Okay, and we'll also talk about something called special IPs or special IPs in tomorrow's class.
Wow, nice. That's the meat of the topic, right? That's the interesting part.
Yeah, it's going to get slightly more practical from tomorrow, Michael.
Yeah.
Right. So now let's talk about CIDR. This is one last very simple concept left out, quite crucial as well in Linux operating systems. So this is an alternative for subnet mask in Linux. So in Windows, you usually use the subnet mask, these values, 255.0.0.0, 255.255.0.0, 255.255.255.0 for each class. Okay. But in Linux, rather than using a subnet mask, you use something called CIDR. Okay, and that is denoted by the number of network portion bits. So in class A, you have only one network portion, which has 8 bits. So the CIDR for class A is /8. For class B, it contains 2 network portions, so that would be /16, 8 plus 8. And for class C, it's going to be 3 network portions, which is 8 plus 8 plus 8. That is /24. So sometimes you might see addresses like this, 192.168.0.1/24. So this /24 denotes the subnet mask, or also called as CIDR. This 24 is what denotes as this subnet mask address 255.255.255.0. Slash 16 denotes 255.255.0.0. And slash 8 denotes 255.0.0.0. So you have to remember that. So whenever you see a slash and a number after the IP address, it's called as CIDR. So don't get confused, guys, when you see addresses like this online. Okay. So yeah, again, a small session, guys, because as I've mentioned, tomorrow I'm going to start the practical part. We are done with most of the important theoretical concepts for networking. So tomorrow we're going to talk about one more practical concept called lab setup installation. How do you install the operating system called Kali Linux, Kali. This is quite crucial for us in the upcoming classes. This is a Linux-based operating system which contains all the tools required for hacking or ethical hacking. They are pre-installed.
Yes, Splunk and all that. Yes. So,
yeah.
So let me ask you. So no two IP addresses are the same ever, right?
No two in your local network, Michael. No two devices will get the same IP. Okay, but if you talk about it in this way, for example, let me explain this in a much better way with a diagram. Let's say this is your house, Michael, and this is my house here. Okay, somewhere. So this is, let's say, there's the ISP in between, Internet Service Provider. ISP. Okay, let's say we are using an ISP like any Verizon. Oh yeah, T-Mobile. That's also fine. Okay, so now, oh, just a second, guys. Someone's at the door. Let me get that quickly. Just a minute. So sorry.
Yes, sir.
Right. So sorry for that. Now let's say there's my router here somewhere at my home, and my router is connected to its own devices. Let's say my laptop, my mobile phone, my smartwatch, and so and so. So my router gets a public IP from T-Mobile. Okay, so let's say my public IP is 1.2.3.4. Okay, and in my own local network, I'm using private IPs like, let's say my router gets the private IP 192.168.0.1. My laptop gets 192.168.0.2. My phone gets 0.3, and my smartwatch gets 0.4. Okay, and let's say, so this is my home here, this huge box. Okay, this is my home network. Okay, let's say Shoaib's home. Okay, and somewhere there might be your home as well, which might be getting its own public IP. So let's assume this is your router, Michael, over here. Okay, and your router gets a public IP from the ISP, which is unique to you. Let's say that's something like 2.3.4.5. Okay, and at your home you have your own devices, your laptop, your smartphone, your smartwatch, okay, your smart TV, and so and so. Okay, and these devices also get a private IP. So your router might get 192.168.0.1. Your laptop could get 0.2. Your smartphone could get 0.3. Your smartwatch could get 0.4. And your smart TV could get 0.5. Okay, so this is your home. Okay, now if you closely observe, your devices and my devices have the same private IPs. Okay, so you are also using the same IPs 192.168.0.1, 0.2, 0.3. I'm also using the same IPs 192.168.0.1, 0.2, 0.3. Now you might have a question. What if your phone and my phone requested for facebook.com? Who does the server respond to? So whenever you talk about a private network, Michael, each private IP is unique in its own local network. Okay, so in my network, my devices have their own unique private IPs. In your network, your devices have their own local private IPs. But when we connect to the internet, okay, our packets travel with our unique public IPs. So if there's a Facebook server here, let's say facebook.com, facebook.com, and if your phone requests for Facebook, the first packet travels from your private IP 03 to 01. From 01, the router transfers the packet to the public IP with 1234, and then from the ISP it reaches Facebook. So this request occurs from 1.2.3.4. And when your phone so this is my phone's request, and when your phone accesses Facebook, it comes from 023 to 01 again, from 01 to 2345 with the public IP, and from there to Facebook. Okay, so our requests are still unique with their public IPs. So when you connect on the internet, each person has their own unique public IP. In your local networks, every home can still use the same private IP. Okay, but they will be unique in their own local networks. Is that clear?
Absolutely clear.
Right. So this is the concept of NATing, network address translation, where you can repeat private IPs as many times as you want. So in all the homes that we have all around the world, they could still use their own same IPs, 192.168.0.1, 0.2, 0.3, and so on. But they're still unique because each person gets a unique public IP. So when all the public IPs are extinct, when all the public IPs go exhausted, then you have the necessity for going to a much higher IP address range, IPv6. Okay, so that's what NATing is. That's how you're still able to use the same 4.3 billion IPs again and again, because each home can use this same private network as many times as they want. Okay, but each home gets a unique public IP. That's important to remember. Okay. Any questions, guys? Kiran,
Yeah, because
Madhu?
that's possible because the ISPs are different and the routers is different for each home, right?
Exactly. Each router gets its own unique public IP. You could use the
Public
same
IP.
ISP as well. You and I could still be connected to the same ISP, but your network and my network gets two unique public IPs from the ISP.
Yeah.
Yours is
Yeah.
2345, mine is 1234. It's unique to each of us. And that's how we are able to communicate.
Okay. Very good.
So yeah, that's that, guys. Nothing further. A small session which concludes our topic on networking. So again, we have learned about IP. Yeah, Mike.
Sorry. So you are going to be the one to take this class, till the class ends, right?
Definitely. I'm going to be the instructor itself, Michael.
Okay. Because the reason why I'm asking is because if it's not you, then it's going to be a problem for me. That's why I just want to make sure.
No, Michael, I'm going to be the same instructor. Don't
Okay.
worry, I'll be
All
there
right.
at the end of the course.
Thank you, sir. Yeah.
No problem. So yeah, that's that, guys. Nothing further. You should be getting the recording from the institute once you have made the payments. And yeah, that's it. I'm going to connect back tomorrow at the same time, where we'll talk about the lab setup installation.
All
Okay.
right.
Have a good day.
Thank you so much,
And
Coach. Yes, sir.
thank you, guys. Bye-bye. Bye, Kiran. Bye, Michael.
Bye.
Mohammed
Bye-bye.
and Madhu, if you have any questions, guys, you can let me know, since this is your first class. Again, guys, I would recommend that you go through the demo video on YouTube from the DurgaSoft website, where you can understand the contents of the course. What we are learning right now is the first topic, basic networking prerequisites. We are talking about the networking fundamentals today. Okay. Tomorrow, we're going to talk about the practical lab setup required. Okay. So if you have any questions, please do let me know or connect to me via my WhatsApp also. And yeah, that's that, guys. Nothing further. I'm going to exit the session. Please do join tomorrow as well, so that you can understand the practical aspect of the course. Yeah, Mohammed, were you saying something? Mohammed, I can't hear you. Your mic's unmuted, but I still can't hear you for some reason. Okay, assuming there are no questions, guys, please do join the session tomorrow as well using the same link. We will talk about the practical aspect of the course. Bye-bye. Have a good day. I'll see you tomorrow.
Okay.
Thank you.
Thank you.